Okay, welcome. We are doing a YouTube video here, and the number one video here is how to evaluate basic expressions. So I want to show you how to do that with positive numbers, negative numbers, and also with zero, involving squared terms, regular x terms, and a constant. So let's get started. First thing you want to do is write the equation that you have in hand. Actually, it's not an equation, it's an expression in this case. And that would be plugging in a 0 here for the x. So that's 0 squared plus 2 times 0 plus 1. We're going to evaluate the 0 squared first, and that's going to give us 0 times 0, which is 0. So that just provides us with 3 times 0 plus 2 times 0 plus 1. If you notice, 3 times 0 and 2 times 0, they go to nothing. So you might as well just wipe those out, and our final value for that expression is a 1. Trying it now with the 2. Putting in the 2 here, we're going to put the 2 in for x squared and also for the x. So 3 times a 2 squared plus 2 times 2 plus 1. I'm going to open up this 2 squared so you know that it's not 2 times 2, but it is 2 times 2, but it's because it's an exponent and you're seeing it 2 times, plus 2 times 2 plus 1. In this case, 2 times 2 times 3, they're all positive, so you know it's positive, and that gives me a 4 times 3, which is 12. And plus this right here, this is a 4, plus that 1 right here is a 1. And I can put these numbers together. 16 plus 1 is 17. So this function, or this basic expression, has a value of 17 when you evaluate it with an x value of 2. And the last one we're going to do in this basic form is a negative 2. I'm going to stick a negative 2 into the x squared and into the x. Once again, I'll rewrite it. I'm going to write it as negative 2 times negative 2 plus 2 times negative 2 plus 1. Negative times positive is going to give me a positive number, so that's already taken care of. I don't need to waste time inputting that into my calculator, and that's going to give me 4 times 3, which is, once again, it's 12. This positive times a negative here, that's going to give me a negative, and I know that's 4, and the plus 1 follows. And now it just becomes a matter of adding positives and negatives, which is 13 and a negative 4, which is going to be a 9. That took a little bit longer than it should have. Sorry about that. So that has a 9 when you put in a negative 2. When you plug in a 2 value, you get a 17. When you plug in a 0 value, you get a 1. We could have seen that right from the beginning, because this little 0 is going to destroy this and destroy this by multiplication, leaving you only with a 1. Now let's move on to function notation, which is more likely what you're going to get in slightly higher levels. We're going to plug in a 3 now, so it says f of x equals 3x cubed minus 2x squared plus 3. What f of 3 means is that we're going to evaluate this expression at 3. I'll try to show you a graph at the very end. So what we're going to do is we're going to put a 3 in there. We're going to put the same 3 in for this x value, and this 3 here is a constant. So it has nothing to do with this 3. That was just part of the basic function. Let's do that. So we're going to rewrite it. 3x cubed minus 2x squared plus 3. In my next step, I will plug in those values. I might run out of room. 3. Because it's cubed, there's going to be 3 of them. So I'm going to put in 1, 2, 3 additional 3's. Minus 2 times 3 times 3 plus 3. These 3's here are going to give me, that's a 9 and that's a 9. They're all positive. 9 times 9 is 81. Now looking at this next segment right here, this next term, which is the negative 2x squared term. Here I have a negative 2 times a positive 3 times a positive 3. Well, that's going to be 9 times 2, which is 18. But you know it's negative. Minus 18. And lastly, we have a 3 trailing it. So this becomes, I like to think of getting all the positives together, which makes it 84 minus 18, which is kind of like 84 minus 20, which is 64, but not quite. So that's going to be a 66. So f of 3 has a value of 66. If this was a graph at x equals 1, 2, 3, the y value would be 66, and that would give us a point right here, which would have a coordinate of 3, 66. For this x value, we get an output of 66. Let's see what the output would be at -2, which is this problem over here. We're going to find out what y value comes out when you plug in a -2. We'll start down here to give ourselves a little bit more room. So once again, f of -2 at 3. We're plugging in 3 -2's because once again it's cubed. So we need 3 of those -2's minus, I'm going to work it down here, minus 2 x squared. In this case, x is -2 once and twice. And again, you have the trailing 3, so we'll put him here at the end. All right, let's evaluate those guys. That's negative times negative times negative times a positive. So you have 3 negatives, so your result will be a negative. Your negative product is what you're going to get from that. I like to think of this as 6 times 4, which is 24. Now looking at the middle term here, which is negative, negative, and negative. You have 3 negatives, so your final product will also be negative. 2 times 2 times 2 is 8, with a following 3 at the end. Combining the negatives, you get a -32 plus 3 for a final result of -29, which means that f of -2 equals -29, which is giving us a coordinate of -2, 29. This is your input, this is your output. Back to our graph over here, a -2 had a y value of 29, so it would be somewhere around here. It would be somewhere around there like that. So this 3 value had an output of 66. The input of -2 had an output of 29. And these points might be associated in some way, some fashion. If you graph this on a graphing calculator, it'll give you a clear picture of where these points really are. All right, well, thanks for hanging out for 8 minutes of your time. I hope this helped. And if you have any requests for videos, you can text me. I'm sorry, you can't text me. We're not doing that. You can email me at ariusrick@hotmail.com. If you have any requests for videos, you can ask me and I can try to make them. Thank you very much and have a good night. Bye-bye.